All right, so I wanted to go over a couple examples from section 3.1 about functions and function notation. So one of the things to understand when we're looking at an example like example 6, where it's asking us to evaluate the function, that is just given a certain input, what does the function look like? And so for this particular function named f, they display it here with the input placeholder as x, but really that's whatever input we choose or are asked to evaluate at. And essentially what this function is, this function f says, according to the input, let's call it a something. These are the instructions to how to calculate the output for f. So we just take whatever something they give us and square it, then add it to 3 times that something, whatever it is, and then subtract 4. And the something is the input, right? So the input is then here and here. So I just basically make these blanks where the input should go based off where these placeholder inputs are at in the given function. So when I'm working one of these, I just like to go ahead and make my shell. I call it a shell because it's just got these placeholders. And essentially what we're going to do is, so in this first one, the input is 2. So we put 2 everywhere there's a place to put the input. And then we just evaluate, which is simply just perform any operations that we can. So this is 4 plus 6 minus 4 equals 6. So f of 2 is 6. And now let's do it again with a different input in B. Same idea. Now let's do the input A. So everywhere there's a place for an input, we're just going to put an A. And so f of A is equal to a squared plus 3a minus 4. And it can't be simplified any further. So we're done. Okay, now let's do a plus h. Now we're substituting, instead of a single value, we're going to substitute a whole expression as the input. And so this is a plus h, a plus h, a plus h. And then just like we did before, now we just need to clean it up, right? So to do some scratch work, I don't like to do a bunch of calculations in the line of the problem. So I'll come over and do some scratch work over here to keep myself organized. So this would be a squared plus plus h squared, which will give me a squared plus 2ah plus h squared. So that goes here, a squared plus 2ah plus h squared plus, now let's distribute the 3. And then from here, we're just going to combine all the like terms. And then we'll be finished with that one. So combine all your like terms. And we have a squared plus 3a plus 2ah plus 3h plus h squared minus 4. So wasn't really any combining to do, just rearranging. And I'm not really worried about this rearrangement here. So if you can get here and there are no further terms to combine, then I'm good with that. So now this last one is a little more complicated. And we have to learn how to read what it's asking us to do in D. And so the first thing I want you to notice, let me get a new color here. I have blue. Okay. So the first thing you need to notice here is it says, essentially what it's saying here, if we ignore those input blanks, is it's saying, take the function f, subtract the function f, and divide by h. Okay, easy enough. So Let's set that up. So f, remember, this is f with no inputs put in. So let's write that. We're going to do, let's have it. So we're going to do f minus f again. And I'm going to put the brackets because when we subtract, it's important that we subtract everything. So we'll just do f again. And then here's the h on the bottom. But again, this is f, and this is also f. So that's how we start. And the only difference is that the first f has a different input than the second. So we're going to go handle that. So the first f has input a plus h, and the second one has input a. And so essentially, at this point, you've done all the setting up that you need to do. And the only thing you'll need to do from here is just simplify this, right? Like, so that's just taking all of this and, distributing, multiplying out, combining like terms, etc. And so you would just continue to simplify that to get your final answer. So let's talk about example 7. Given this function, these are the instructions for the function h with input p. Evaluate h of 4. And so remember that this guy is the input. So it's telling you there's a new input. It's defining the input for the question. So if I want to find h of 4, everywhere there's a p, I'm just going to put a 4 instead. Same idea as before. And so this would be 16 plus 8, which is, I guess like 24 or something. Okay. Example 8 says, given the function h in terms of p, solve for h of p equals 3. We'll check this out. It says that this h of p, the output of the function, it's no longer giving me the input, it's giving me the output, which is that guy right there. No, sorry. Let me back up. This is the output, and the output is 3. Sorry, I misspoke. Forgive me, I'm sick. So this is the output of the function. And remember, when we have some sort of equivalence like this is saying in plain English that h of p is 3 in this case. So I can just replace this h of p with this 3. Why am I not plugging in for p? Because it doesn't tell me what p is. That's what it wants me to find. So once I've plugged in the output for this particular question, I'm just going to go ahead and solve. Now this is a quadratic. This right here. And to solve a quadratic, we're going to use factoring or the quadratic formula. But both of those only work if there is a 0 on one side of the equation. And then we'll factor to solve. And I'm going to assume that we can do that. And if we cannot factor, there is a practice in Delta Math that's optional to help you get unrusty on your factoring. Okay. Example 9 asks us to express the relationship given as a function, p equals f of n. And so what this is essentially saying is that we need to solve this for p so that what we have is a rule in terms of the variable n. And so we're just going to, use the miracles of high school algebra to do so. We're going to isolate p. And so we'll start by subtracting 2n from both sides. And then we will divide everything by 6. So 12 divided by 6 is 2 minus 2n over 6. And that simplifies a little further to n over 3. And so P is f of n. This is just different notation for the output of the function. So that's 2 minus n over 3. Why is that not writing anymore? Oh, because I have the eraser on. 2 minus n over 3. See, this just says that the rule for the function f is this in terms of the input n. Okay. Expressing the equation of a circle as a function. So this is like some of your homework problems where something isn't a function when we express it in terms of a function f of x that's written in terms of x. So here we need to solve for y. So let's do that. So we're going to subtract x squared from both sides. And we're going to isolate y by taking the square root of everything on the right-hand side. Notice this has broken into two different things. And so that essentially means when you see that for one input, you're going to get two different outputs, right? And so that violates the rules for a function. So when you see that, when you're solving, and I'm asking you, is the relationship a function? If you see that plus minus, it's not going to be a function. So you have some problems like that. All right, and I think that's all from this section. We'll make some